Despite all we've learned about the universe, including what it looks like and what exists in it, there remain many cosmic unknowns. Now, the largest and most expensive and complex space telescope ever built is now in space and heading to its final destination. We may soon discover the galactic unknowns, so join us as we present NASA's shocking discovery with James Webb Telescope changes everything. Number 6. In search of the unknown. To look back in time at the cosmos' infancy and witness the first stars flicker on, you must first grind a mirror as big as a house. Its surface must be so smooth that if the mirror were the scale of a continent, it would feature no hill or valley greater than ankle height. Only a mirror so huge and smooth can collect and focus the faint light coming from the farthest galaxies in the sky, light that left its source long ago and therefore shows the galaxies as they appeared in the ancient past when the universe was young. The very faintest, farthest galaxies we would see were still in the process of being born when mysterious forces conspired in the dark and the first crops of stars started to shine. But to read that early chapter in the universe's history, to learn the nature of those first, probably gargantuan stars, to learn about the invisible matter whose gravity coaxed them into being, and about the roles of magnetism and turbulence and how enormous black holes grew and worked their way into galaxy centers, an exceptional mirror is not merely enough. Moreover, this is the story that scientists tell us of the dark ages that gripped the universe before the first stars ignited. And very soon, they intend to show us that time, or rather, how it ended, how the cosmos ultimately became filled with light. They'll do it using the biggest telescope ever placed beyond the Earth, the James Webb Space Telescope. It's intended to succeed the Hubble Space Telescope as NASA's flagship mission in astrophysics. Number 5. What is JWST? The James Webb Space Telescope was originally called the Next Generation Space Telescope, or NGST. It was called Next Generation because Webb will build on and continue the science exploration started by the Hubble Space Telescope. Now, this space-based observatory is named after James E. Webb, NASA's second administrator, who's best known for leading Apollo, a series of lunar exploration programs that landed the first humans on the moon. However, he also initiated a vigorous space science program that was responsible for more than 75 launches during his tenure, including America's first interplanetary explorers. The James Webb Space Telescope, also called Webb or JWST, is a large space-based observatory optimized for infrared wavelengths, which will complement and extend the discoveries of the Hubble Space Telescope. It has longer wavelength coverage and greatly improved sensitivity. The longer wavelengths enable Webb to look further back in time to find the first galaxies that formed in the early universe and to peer inside dust clouds where stars and planetary systems are forming today. Now, in order to do this, Webb has a much larger primary mirror than Hubble, which is almost 2.7 times larger in diameter, or about 6 times larger in area, giving it more light-gathering power. It also has infrared instruments with longer wavelength coverage and greatly improved sensitivity than Hubble. Also, Webb will operate much farther from Earth, maintaining its extremely cold operating temperature, stable pointing, and higher observing efficiency as compared to the Earth-orbiting Hubble. Number 4. The Objectives of JWST. So there are 4 goals of the Webb telescope. First, scientists want to study the first stars and galaxies formed right after the Big Bang. Normally, humans wouldn't be able to see this because, as light travels through the universe, it gets stretched and becomes infrared, which is invisible to the naked eye. But an infrared telescope will be able to detect this light, which has been traveling toward Earth for more than 13 billion years, essentially allowing the Webb Big Bang to look back in time. And this leads to this second part of the mission, comparing the galaxies from the past to those of today. Looking at galaxies is a useful way to see how matter is organized on a gigantic scale, which in turn gives us hints as to how the universe evolved. The spiral and elliptical galaxies we see today actually evolved from different shapes over billions of years And one of JWST's goals is to look back at the earliest galaxies to better understand that evolution. Third, because infrared radiation can pass through astronomical dust, which can't be viewed on a visible light telescope like Hubble, the Webb telescope will be able to study how stars and planetary systems such as our solar system formed, at least according to NASA. And finally, the telescope will study planets outside of our solar system to see if there are any signs of life or if they have atmospheres capable of sustaining life. Number 3. The power of JWST. JWST is one of the most anticipated space science missions of the 21st century, as it has the ability to reshape astronomy and astrophysics as we know it. That's because the telescope is the closest thing we have to a time machine. Sporting a 21-foot wide gold-plated mirror, JWST will be able to see in the infrared with incredible sensitivity. It'll be able to see objects that are 10 to 100 times fainter than what the Hubble Space Telescope can already see, and it's going to be capable of seeing things in 10 times better detail. It'll gather light from stars and galaxies located up to 13.6 billion light-years away, light that's taken 13.6 billion years to reach the telescope's mirrors. Now, since the universe is thought to be roughly 13.8 billion years old, the galaxies that JWST will be observing likely formed just 100 to 250 million years after the Big Bang. Our universe was in its infancy then, and JWST will be providing us with baby pictures. It's an astounding idea that you might still be able to witness such a thing. But that's the consequence of light having a finite speed in a vast and expanding cosmos. If you keep probing deeper and deeper, you should eventually get to retrieve the light from the pioneer stars as they group together into the first galaxies. Number 2. The first of many things. In the earliest moments of the hot Big Bang, the universe formed individual protons and neutrons, and then those protons and neutrons fused together in the first few minutes to make the first heavier elements in the universe. Now, we've never seen an example of pristine stars before, and James Webb will be our best opportunity to do so. Its infrared eyes can peer back farther than any observatory, including Hubble, and should break the cosmic record for the earliest, most pristine stars ever seen. We have theories that they should be very massive and short-lived. James Webb is expected to give us our first opportunity to spot and study them. At the limits of today's observations, we've spotted black holes that are as massive as about 1 billion solar masses, a whopping 13.2 billion years ago when the universe was merely 5% of its present age. How did those early black holes get so massive so fast? It's not impossible, but it certainly is a challenge for what our current theories to explain what we see. Now, we would need, for example, a seed black hole of about 10,000 solar masses to form just about 100 million years after the Big Bang, and it would then need to grow at the maximum rate that's physically allowed for the entire time just to get there. Either these black holes started off bigger than our theories expect, or they formed earlier than we realize, or they can grow faster than we think they can. But that's where James Webb should shed a remarkable amount of light on these dark objects. Number 1. The ultimate goal. So the ultimate goal of the $10 billion JWST is to find a planet similar to Earth. But it would require a very lucky combination of circumstances because they're likely to be rare in the solar neighborhood and very faint compared to the parent star. In March of 2017, it was reported that a nearby star called TRAPPIST-1 is orbited by 7 planets, similar in size and mass to Earth. If we manage to identify the presence of life on a planet similar to those in the TRAPPIST-1 system, then we can start measuring how frequently biology emerges in the universe. It's been reported that JWST is planning for 5 transit observations of TRAPPIST-1e. The goal of the transit observations is very simple: to figure out if the planet has an atmosphere or not. Since we have no clue of it, we just can't wait to know the truth. So what are your thoughts about this NASA mission? What do you think about the James Webb Telescope? Let us know in the comments below. And we hope you enjoyed watching the video as much as we've enjoyed bringing it for you. We'll see you next time. Goodbye.